Hello guys, welcome to today's class where we'll be looking at the continuation of the previous example, example 2, where we'll be looking at Roman figure 3 and Roman figure 4. Section D and section E. In section D, we are asked to find the identity elements of each of the elements of the set if they exist, that is, each of the members of the set if they exist. So for the very first thing we're supposed to do is to remember our idea of identity elements. Remember, for identity elements, we have A, B, D, and E. So for identity elements, identity elements is what is any value that will be operating with each of the original values to give us the original value again. That is what the identity element is. So the identity elements for A, we don't know. The same thing for B, we'll be looking out for whatever the identity element will be here. For D, the same. That is, what will we operate with D that will give us D again? That is what the identity element tells us about. So when we're using the table, this is how we go about it. We just simply pick out a value from the table that will actually tally with what we are going to do. So for A now, to get the identity element of A, for A, go to the table, we look at our A, and then we look at our A, then we say, from this A here, what are we going to operate with A on the second axis that will give us, what are we going to operate with A on the second axis that will give us A again in the answer section? So this is the answer section. We have A here. This is the answer section. This is the answer section. We have A here. What are we operating with A that will give us A again? From this table, we can realize that when we operate this A with this A, we get this A. So we realize that A here is this identity element of the A here. So we can bring it down. For B, to get the identity element of B, we consider B on the first axis. We see B here, consider this B. Looking at what can we relate with this B on the second axis that will give us B as its identity element. As a value again. The only value you can relate with D that will give us B is my D. So my D here becomes the identity element. My A here is the identity element. So my D is the identity element in this case. D is the identity element here. I come here and I pick my D. For D now, what is the identity element of D? For D. Looking at D, considering D, this is my D. What will I relate with D on the second axis that will give me D again here, which is here? So the only thing I'll relate with D is also A again, and then means my identity element for this one is also A. For my E, to get the identity element of E, what am I going to relate with this E that will be on the second axis that will give me E again? It is actually my D again. So my D here will be the identity elements for this. So I can boldly say now that was the identity element of A and D is A. That means the identity element of A and D are actually equal, and they are the same thing, which is what? A. While for B and E, they also have the same identity element. An identity element for B and E is actually D. So now that I've gotten the identity elements, we can move on to the inverse element. Moving on to the inverse element, the question here tells us find the inverse of each element if it exists. Now that means if we can detect that there's an inverse of the element, then we should actually find the inverse of each of the elements. But before we can detect the inverse of the element, we must remember and recall the formula for the inverse element. Recall that for inverse element, we express the inverse element as the relation of a particular of an original variable operating with the inverse give us the identity element, of which we said we have to have operated we have to have operated on the identity element before we can work on the inverse element. So for the A, this is it for A now. We'll be considering the identity element of A, and we have already gotten the identity element of A before. We got the identity element of A to be A. So if the identity element of A is A, we're looking for the I. I here is what we're looking for. So in short, we know that we're looking for what we can operate with this A that will give us the identity element of A, which we got to the A here. So in short, you look at your table on the second axis, what can I operate with A that will give me A again? Go to my table. What will I operate with A to give me A? This is A on the first axis. A on the first axis. What will I operate with this A that will give me this A? I realize that the only thing that will give me this A on the second axis, that will give me this inside the box here, will be this A on the second axis. Every other thing here won't give me that. So that means my inverse element of A is also, so inverse of A is A. We'll go to the next one. We look at for B now. For the inverse element of B. For inverse element of B, we also operate it the same way. We say B operation, the inverse element should give us the identity element. That means the inverse element which we are looking for is what is the unknown here. And we are putting our identity element from the previous question for B. The identity element for B is D. So all we need to do, just slot it here, and then go to our table and say, what do I need to operate with B that will give me D on the second axis? So go here. What do I need to operate with the B on the first axis? This B on the first axis. What do I need to operate with this B on the first axis that will give me D on the second axis? So the only thing that will give me this D on the second axis, B operating with D here will give me B. I mean, so I know that what this B here, when it operates with this D, it gives me B. So since I know the identity element of B is D, that means since I know the identity element of B is D, and I know for inverse element I say B operation, the inverse element giving me the identity, which is D. That means what will I operate? Okay. We come here, we look at the second one, we say B operation I equals to E. We know that what our I here is the inverse element. We have gotten the identity element, which is D. Now B operation what will give us D? We know B is on the first axis. B operation what will give us D? So we come here, we say B operation what, that is on the second axis, what are we going to be operating on? What we are looking for, what will be operating on that will give us D here. So we realize that the only thing that we'll be working on here, it won't be D rather, it will be E. So it is only the E, it is the E that will be the identity element, the inverse element of B. Why? Because since D is for, we already have B operation. Figure out what that inverse will be. We know that what B operation something on the second axis, something out of this 4 will give us this D. So we realize that the only way that we have that intersection is when we relate it with E on the second axis. So that is what happens here. We'll go to the next one. Go to the next one now. It means that our inverse here is E. That means the inverse element of B is E. For the next one, we look at D. D operation, the inverse, should give us the identity element. Where it is the inverse we're looking for. If that is the case, then a particular unknown value equals to, remember we have gotten the identity D. Identity element for D was given as A, so we can easily just go back to that and say, since this was given as A, the identity element for D is A. Now you go back to your table, D operation what will give us A. Look for D operation what will give us A. And if you look at D here, look at D operation what will give us A. D operation what will give us this A here. Now the only way we operate D with something that will give us A here will be also D. So that is the only value that you operate with D that will give you A. So you know D operation D is going to give you A. So you know definitely inverse element of D is actually D here. So I say inverse element of D is D. So now that I've gotten the inverse element of D, I can get the inverse element of the final one, which is what E. I say E operation what is going to give me the identity element in this case. So I'll be using the identity element, I'll be using so as for not to get confused. You know, EI is the identity element. And if that is the identity element, then E here. So what will relate with this E? It means that what, since my E here, operation what will give us the identity element of E that we got already. We already got the identity element of E before be D. So taking that, you know, our value here will be D, and then operation what will give us D from our table. So we go to our table, E operation what will give us D. E operation what will give us D. We're looking at E. Operation what will give D. We know that this is the D that we'll get. But then what will we need to relate with this E to give us this D? The only thing that we'll be able to relate with here that will give us that is what? Is our B. We know that when we operate E and B together, it gives us D. That means B is the missing value here. And then that means B becomes our inverse element of D, of E. So I've been able to, I can say that was the inverse element. So this is where we call it a day, and then we realize that was to get each of these values they're actually distinct to each of the members of the set. For the A, we realize that what the A had a different identity element, although it had the same identity element with the C, and then the E, with the D, and then while the B and E also had the same identity element, theirs were different from the A and the D. So even this, and the same goes with the inverse element, they each have their own individual inverse elements. So in the next class, we'll be looking at a different topic altogether. So in the next class, we'll be looking at another example on how we can operate on the inverse element, the identity element, and the commutative properties based on the operational table. See you next class.